In this video, I will continue building the Caterpillar game. But first, let's take a look at how to build a multiple binary project. As a neuroscientist, I find it challenging to understand some of the online documentation for Rust. To overcome this, I have approached it as I would when dealing with my electrophysiological preparations, experimenting until I find what works. I experimented with 3 different methods for creating multiple binary projects. The project directories are named bin demo 1, bin demo 2, and bin demo 3. First, let's take a look at the first one, bin demo 1. Now, let's see what's inside the src folder. There is a folder named bin. The bin folder contains 2 source files and 1 subfolder named binary 3 with 2 files, main.rs and add.rs. Please pause the video to examine the code. This is the project's tree view. The cargo.toml file contains minimal information. There are 3 source code files. The commands to build and run the binaries are also included. In summary, the project uses a shared manifest file in the bin directory within the src directory for the source code. Let's proceed to build and run the binaries. What happens if we place a source code file named binary0.rs outside the bin folder? The cargo system did not recognize the binary0.rs file. Let's rename it to main.rs and rebuild the project. This diagram summarizes what we have been experimenting with. If we remove the bin folder, we have the basic project structure. This is the second project. The folder contains 2 subfolders and the manifest file. Let's take a look at the first folder, binary 1. Binary 1 contains a cargo.toml file and a folder named src with a file named main.rs. This shows the organization of the project, which has a top-level cargo.toml file and two cargo.toml files residing in the subfolders. The source code is very simple. We can build and run the project like this. This is the tree view after building the binaries, from which we can see that all the packages share the same cargo.lock and output directory. In the third scenario I tested, there was no bin folder. The src folder is not required. Instead, the bin tables are used for binary target settings. These are the commands to run the binaries after a successful build. Previously, we built two projects, Worm2 and Worm3. Now, I am going to reorganize our game into one package. We will create a folder named Caterpillar. Open the folder and create 5 subfolders. Let's focus on the Worm2 folder. I have transferred the source code from our old Worm2 project to the new one. The code in the new Worm3 and Worm4 folders comes from the old Worm3 project. Additionally, I have created a manifest file containing essential information about the source code paths. Next, we will modify the food.rs and game.rs files to bring our game one step closer to the final stage. The struct declaration remains the same, but a new field has been added. In the old version, the food existed in one of two states, letter-free or letter-carrying. In the new project, the food still exists in one of these two states, but now it is composed of two parts, the head and the tag. This significantly increases the size of the code. If the food carries a letter, a circle is drawn as the tag, the letter is drawn inside the circle, and finally, a circle is drawn as the head. Otherwise, we draw the tag, create a rectangle object as the head, fill the head, create two eyes, and fill the eyes. Let's examine the handling caught method in the game.rs file. We have renamed the field name from letter to tag. We need the position of the tag. Based on the picture, if we know the position of the head, we can calculate the position of the tag. Let's use the variable POS to represent the position of the head. Then, we can calculate the tag position like this. Now, let's update the update method. The code indicated by the green curve generates the startup interface after running the application. The interface consists of a side panel and a central panel. The return command is used to proceed to the next iteration, skipping the code below. This is what the interface looks like. We will now hide this part of the code. The following part of the code is responsible for quitting or resetting the application. No changes are made for this part of the code. Here, we handle the worm and the foods directly. We obtain the canvas size for the worm and the foods here. We create more space for the following code. This part of the code initializes a new game or displays the game over interface depending on the game state value. Finally, we paint the worm and the foods. Let's run the application.
Hamster. Hamster. Kangaroo.
We need to make some minor changes to the worm.rs file. For the complete code, please check my GitHub site. Thanks for watching.